Hi everyone. Assistant Professor, Department of IoT. Today we discuss upon flip-flops and latches. So which are sequential circuits. We have already discussed about logic gates. So logic gates is a combinational circuit. Flip-flops is a sequential circuit. It can store one bit of memory at a time. So there is a difference between combinational logic and sequential logic. So see the block diagram of a sequential circuit. So in the sequential circuits, the output of sequential circuits depends on present input and previous outputs. You see this block, this one is combinational circuits from the output. So the output, we are taking that output and that is stored in our memory element. That output is given as a considered taken as a current state, and it is given to the combinational circuit. So combinational circuit, the output it depends on external inputs and internal inputs. That is current state. That is previous output is taken as present input. So this is the block diagram of latches. So latches, what is a latch? Generally, what is a latch? In our home, we are using latches to lock an information, to lock anything, to protect anything, we use latch. So in electronic circuits, latches means once the element is stored, once the data is stored, without any trigger pulse from the outside, we cannot put the data inside, and also we cannot take the data out from that element. So that's why we call this as a latch, right? So sequential circuit, it contains a set of inputs and outputs. The outputs of a sequential circuits depends not only on the present inputs but also previous outputs. Okay, the present output we call that as a present state. Right. Therefore, the sequential circuit contains combinational circuits along with the memory storage element. So the entire block, the entire unit, we call it as a latch. So there are different types of latches. One latch is derived from the another different types of flip-flops. The difference between latches and flip-flops is flip-flops we need a clock pulse to operate. For latches, just if we give enable input, it starts working. So that is the latch. It is the basic of element of a flip-flop. Okay. So therefore, sequential circuits contain combinational circuit along with memory storage elements. Some sequential circuits may contain combinational circuits, but only memory element. Memory element and combinational circuit together we call it as a sequential circuit. Okay. Then what is a latch? Latch is a building block of sequential circuits capable of storing one bit of information. Store one bit of information. It has two output states, Q and Q complement. We call that as Q bar. Q and Q complement, there are two inputs. It is built from logic gates. Logic gates is the basic unit of a latch. Latches does not have clock signal. Instead, it has enable. Flip-flop has clock signal. Latches have enable line. Output changes only when enable input is applied. When enable is 0, it contains the memory, that is previous input. If we are enabling, if we are giving 1, that is high level, voltage is high level, then it gives the output. So then latch is level triggered. So there are different types of triggering, switching on the system, the device latch. There are different types of triggering. We discuss one by one. Okay, right. There are two types of triggering. So what is a trigger? What does mean by a trigger? The state of a latch or a flip-flop is switched by a change of control input. So the control element which operates the flip-flop and latches, we call it as a trigger. There are two types of triggering, level triggering and edge triggering. So see the clock pulse in the diagram in this. So here this is a clock pulse. Top it is highlighted positive level. This 5 voltage high level we call it as positive level. If the device operates on the rising edge, we call it as positive edge. When the device is triggered in the down, see the down arrow. This is negative edge triggering. So at the edge, at the clockwise edge, device it enables the device to produce output. Okay, that is triggering, right? This is positive edge triggering, rising edge, falling edge, negative edge triggering. So see here in this diagram, this is rising edge. The level high is 5 voltage, it is low is 0. High usually in binary we are taking that as 1, low we are taking that as 0. This is rising edge, this is falling edge. Otherwise positive edge triggering, otherwise negative edge triggering. Right. So these are different difference between a level triggering. Then, what are the different types of latch? One is SR latch, SN set, R means reset. D latch, D means delay or data, usually data. T is toggle flip-flop, toggle latch, JN is next advanced. So we can construct SR latch using NAND gates and NOT gates. So NAND gates also, mostly NAND gates are used. The logic behind NAND gates is applied to produce its truth table, characteristic table, and excitation table of SR latch. We can produce, we can develop flip-flops, latches using NOR gate also. Here we discuss upon NAND gates. See the gates diagram. So here the output, the Q, that is Q, the output is taken and give that to as an input. Then we are taking Q complement output and it is given back to one of the gates as an input. Okay, so this is again we are using feedback. This is latch. So for output, for each output, we are considering the previous outputs. Okay, previous outputs are taken as the input. Okay, so this is SR latch. Right side, see the logic symbol of SR latch. There is one enable symbol. So here below, what you are seeing is a truth table of a SR latch. If we give enable, it gives output. Okay, when it is 0 0, there is no change. When it is 0 1 as input, it is a reset stage. When 1 0, when S is 1, there is set is 1, it is set state. When both are 1, okay, both inputs are 1 high means it is indeterminate, it is invalid, not used. So that is the disadvantage of SR latches and SR flip-flop. Okay. So here both the inputs are 0 means it is memory. It retains its previous input. If reset is 1 means it is the output is in reset condition. If set input is 1 means the latch is in set condition. When both the inputs are 1 means it is indeterminate. It is not valid. Okay, from this truth table, we can derive one excitation table with the say Qn plus 1. Qn is a memory, Qn plus 1 is output of a present state. S and R are inputs. Okay, so here this table we call it as an excitation table. Okay, so we can derive characteristic equation of Qn plus 1 using this table. Okay, from the data 0, 1, 0, 0, 1, 1, then don't care, don't care. Using that, we can draw one corner map and from that we can write one equation Qn plus 1 equals S plus R complement and Qn. This is the characteristic equation of SR latch. This one is excitation table. That's all about SR latches. We discuss the remaining D latch, okay, JK latch in the next class. Thanks for watching. Thank you.